Hey everyone, it's Alice here from Top Mark Science, and today we will be looking at types of forces. Throughout this video, we will be exploring names of forces, how we measure forces around us, and some examples of forces acting on different objects. Let's get started. Forces are everywhere, in the universe, in the car, when you walk, and ideas have been developed over time. You may have seen this guy before and heard the story of the apple, which got him thinking, what is this thing causing the apple to fall to the ground? Which created a light bulb moment, and the idea of gravity was born. A force is a push or a pull that allows objects to change their speed or direction or even their shape. A force is a push or a pull that is measured in units called newtons. We give this unit the capital letter N, and we can measure forces using a Newton meter. More on this in another video. So back to this. Diagrams like this look like the apple is floating, but we know it's falling down from the tree to the ground. What forces are acting in this time? Well, there's a force acting from the core of the apple in a downwards direction. This force is called weight, or it can be referred to as gravity. But there is also a force acting in the opposite direction. As the apple falls from the tree, air particles will collide with the apple, called air resistance. Air resistance is a contact force. The particles contact the apple as it falls. Whereas gravity is a non-contact force. No contact is happening for that weight to occur, just an interaction of the apple's mass and the Earth's gravity. Pause the video here for a mini checkpoint. Answer the 3 questions on the screen, and if you finish, try the challenge. Let's see how you got on. Marking pens ready. Firstly, forces are a push and a pull. They can change speed, direction, and shape of an object, and they will either be contact or non-contact. The challenge was to name some examples and describe how these forces act on objects. So if you had a go, well done. If not, feel free to make some notes as we go along. One example is weight or gravity. Weight is an attraction that acts down on an object to pull it towards the centre of a body. We also have air resistance and water resistance. These are both caused as objects collide with air or water particles as they move. They act in the opposite direction of motion. In this case, the trophy is falling down, so resistance is acting up. Upthrust is a force that occurs in water and is caused when an object displaces water. In other words, pushes the water out of the way to take its place. As indicated in its name, it acts up on the object. We also have applied forces, a force caused when an object physically applies a force to something else, in this case, pushing the trophy along the table. This applied force can then cause friction, which is the result of 2 objects rubbing against each other and act in the opposite direction to motion. So if the trophy on the table is pushed to the right, friction acts to the left. Then there's a reaction force, just the equal and opposite reaction of an object pushing down on it. For example, the weight of the trophy acts down onto the table. So the table pushes back onto the trophy, opposite in direction but equal in magnitude, amount. And finally, the magnetic force, which is a force exerted by magnets pushing apart or pulling together, depending on the poles favour attraction or repulsion. Good job, everyone. Let's look at some of these in more detail then for more practice. Pause the video here and sort the forces we have just gone through into contact and non-contact forces. You can place them into a sorting table like mine. If you finish, have a go at the challenge, which requires a little extra thinking. Let's see how we all got on. Get ready to mark your work. Our forces can be sorted like so. As you can see, most of them are contact forces because they require some kind of contact to work, except for weight and the magnetic force. Good job if you got some or all of these correct. If you did the challenge, we will look in detail now at how we display the direction and sizes of forces. We use force diagrams. Don't worry, you do not need to be an artist to draw these. All you need is a box instead of the object, an arrow or two, and a dot, preferably in the centre of the box to show the centre of mass. The size of the arrow indicates the size of the force, so a small arrow means a smaller force, and a larger arrow means a larger force. And we can draw these together, and their direction will depend on the direction of the force acting. Simple, right? I will guide you through some examples now before some independent practice. Let's say I have a box on a table. It's not moving, so it might be tempting to say that there are no forces acting on it. Well, we do. The force of weight down and the reaction force up. Now let's say someone comes along and pushes the box out the way. We still have the box's weight and reaction force, but now we also have the applied force and friction acting in the opposite direction as a result of the box rubbing against the table. Voila! Arrows, directions, and labels. We can also show the magnitude of the forces like so. Remember, forces are measured in newtons, given a capital letter N. Okay, another example. This car. Don't worry about drawing the car. Draw a box, much easier. A dot in the middle, weight acts down, reaction of the ground back up onto the car. And this car is in motion, so we have a thrust force. And air resistance acts back onto the car. Both show the same thing, only one is more simple to look at and easier to draw. Pause the video here and use what we've just gone through to draw each scenario listed here. No magnitudes have been given, so you will not need to worry about the sizes of the arrows at this point. If you finish, try the challenge. Let's see what you've drawn and give you some feedback then. Marking pens ready. This person has jumped from a plane and has deployed their parachute. I start with my box and a dot. Their diagram would look like this. They are falling towards their ground. Their weight, due to gravity, is acting down and air resistance in the opposite direction. A rocket still has the force of weight due to gravity as it launches. And as it launches, we have a thrust force. But as long as it's in the Earth's atmosphere, we still have air resistance acting against the direction of thrust. Your plane also has thrust and air resistance, just acting in a slightly different way. It also has weight, but now there is a force called lift, lifting the plane up. Simplifying this diagram should look like this. A boat will have all sorts going on because it's exposed to both air and water, allowing both forms of resistance along with thrust, weight and upthrust to act on it. If you gave the challenge a go, there is a good list of things that you could have thought of, but some key factors that impact the size of forces in these scenarios might include the speed of an object, which can change thrust and air resistance on it, weight, which impacts the size of the reaction force, the size or surface area of an object, like a boat or parachute for example, which impacts on several forces like those listed. And the list could go on, but those are some key ones. Now it's time for our end of video quiz to see what we know now. Question 1. Forces are a push and a pull. Nice, easy one to begin with. Question 2. Name one non-contact force. It will either be weight, gravity, or magnetic. Question 3. Finish the sentence. The reaction force acts equal in size but something in direction. Opposite in direction. Question 4. If someone runs faster, what force increases? Bonus point available for what force stays the same. Air resistance will increase, weight stays the same, or gravity. And final question number 5. What could we add onto this forces diagram to learn more about the situation? The number of newtons. Well done, guys. Pause the video here and rate your progress on the traffic lights. This will help you identify areas you need to work on moving forwards. Thank you so much for watching this video, guys. If you enjoyed this video and would like to see more from Top Marks Science, you can like this video and subscribe to this channel. I'll see you next time.